In these sections, I will provide example of each type of the outcome that make the mock abstract allow us to know what appropriate statistical method for each research. Remember in the previous slide that there are 4 types of the outcome which determine statistical method. So example 1, I have 2 examples for continuous, so I put 1.1 here, that if there are 2 groups of the independent of study and independent outcome, we put something like effect of green tea on the body weight as the research title. So here, when we start the conclusion, we put like green tea can reduce body weight. So you see, it is something that you expected to get. And if you get like this, it will be very beneficial, will lead to some recommendations that change the practice or accepted widely. So that is why it's convinced you to do a research. But in this bracket, reduce, it's really expected. But if not as expected, like not reduce or unclear, that means you need to accept and it still be beneficial, something like that. So I put it here as it could be changed based on the real results in the future. You can see this is quantifiable, right? Reduce means you're looking for the mean difference between the 2 groups, the group with and without green tea. So quantify mean difference. That means you have the mean weight in green tea groups and the mean weight in group without green tea, 2 mean to get the comparison measurement magnitude. The 2 number, there are 4 operations, 4 possible operations, plus, minus, divisions, and multiplications, right? But the adding or the plus or the multiplication cannot provide any magnitude about comparison. So just the subtractions, one minus another, which is the weight reduction, or the ratio one divided by another, which is the ratio of the weight, can be used as the measurements of comparisons. So you see, it's quite easy, quantifiable, easy to know the outcome. You know, here you specify body weight. This is the outcome. So this is an example of a good conclusions that is quantifiable and easy to know the outcome. Then present the main findings in the results sections in this format. You know, I highlight this one. Say the experimental group had a lower weight. You know, interpret the results here. Lower weight mean the difference in this direction. Green tea is lower than the control group, and then put the mean difference I just highlight this because it is the magnitude of effect, and this is how large of its with the confidence interval and p-value. This format ensure the main findings is presented and comply with this format. Then provide details in the method sections that allow us to know what is the statistical methods to be used. So put the design here. You see, independent mean parallel groups and measures only once at 6 months after the study start, and then therefore to get the mean difference adjusted for the covariates that could affect the difference. This is the multiple linear regression. And then the sample size calculation will be based on the linear regression. I just put this just to remind us to plan a statistical analysis in the way that consistent with the main components here for continuous outcome independent group, and then see if there is correlated outcome among observations or not. So there is no such issues here. Then we select the most statistical method, which is multiple linear regressions, and calculate the sample size based on that. But if there is correlated outcome, you see this one, everything the same, right? So reduce body weight. But since we need to account for the correlated outcome means that randomized control trial to parallel groups, but the outcome were measured at baseline, 6 months and 12 months. So there are 3 repeated measures. Now, what we need to plan for is how can we analyze the weight for 3 occasions in each group. The baseline is not the effect of the green tea. At 6 months is the early effect, and the 12 months is the long-term effect. So then we need to provide the magnitude of effect of at 6 months, at 12 months, and overall both point of measurements after intervention, and also accounted for baseline, especially if there is imbalance between baseline between the 2 groups. It is essential. How to handle this? There is a statistical method called ANCOVA, or analysis covariance, that can handle this well. And also the generalized estimating equations, or GEE, for an overall effect post-interventions, not each follow-up visit separately, but all, you see. So it's really planned based on both the design and also what we will present in the results section. With this, we can base our sample size on the ANCOVA. And you see, this is an example of presentation, say, after adjusted for baseline, and covariates, other covariates, whatever, like comorbidity or whatever that could influence weight, which is the outcome, be adjusted for them. Then say the experimental group had a lower weight than the weight of the control group with adjusted mean difference rather than the unadjusted one, we adjusted according to this. Of what? At 6 months and also at 12 months, you see, we know its immediate effect, its long-term effect. Then we can justify it can reduce in what way. And also in overall both post-interventions. So this confirms the principle of let the data talk as much as possible. But use this principle, the continuous will lead to get the mean difference, but more complex due to complex design. Don't worry that you never know about the ANCOVA, the GEE, even you don't know it. But if you can know this is a continuous and the weight is measured for 3 times for each person, so it's not independent. It depends on the participants or the subjects in the study. Then we need some special statistics to handle that correlated outcome. Just that I want you to know. Okay, we finished about the continuous outcome. Next, the categorical outcome. In fact, there are 3 types of categorical outcome. One is the dichotomous, which is I put as the example here. Second is the polytomous, more than 2 possible way. And another is ordinal, the one that more than 2 groups, 2 possible way and can be ranked. We will not cover that. To get the idea about how type of outcome guide all these plans. So again, start here. I change from weight now to hypertension, which is the dichotomous outcome that yes or no hypertension. And then the conclusion say, rather than reduce weight now, can reduce odds of the hypertension because we plan to present the odds ratio as the magnitude of effect, the measure of the magnitude of effect, and this is the magnitude, measure of effect and magnitude of effect, I would say. That's the odds, and the odds is the indirect measurements of the risk, but it's more stable than risk or risk ratio. So that's make this. Maybe some people say reduce risk of hypertension, no problem, because it's the indirect method to estimate risk, no problem, still acceptable. And from this, quantifiable, easy to know the outcome, you can see here. Then you see the example of how we present the outcome. Just change the measure of effect from the mean weight, mean difference of the body weight to the odds ratio. Ratio of the odds of having hypertension in T group compared to control groups. I say reduce for 30% means that the effect here is about 0.7. 0.7 is 30% less than 1. 1 means no different. If more than 1, we say how many times the risk or the odds of the experiment group compared to the control group. So that's how to interpret the measure. And also the method sections. So it's just the same as the previous one, but just change the type of outcome like this and specify This is the multiple logistic regression. Also, the sample size is based on that. Actually, in the sample size in the format of the abstract, it's not put like based on this. No, I just remind you that this is the method of sample size calculations, but in the presentations you need to present the number of sample or the sample size that obtained from this way of calculations. Okay, so the third type of the outcome is the numerical count or the Poisson count. Details I put in the lecture of overall statistics, but here, mock abstract can guide the SAP the same way. Effect of green tea on hospitalizations among elderly. We consider hospitalizations, which is the outcome here. It seems to be yes or no, right? Dichotomous, hospitalized or not. But actually, each individual can have more than one episode of hospitalization. So this is numerical count, to be fair. If we treated this as dichotomous, that means only a single hospitalization, we say yes, hospitalized, ever been hospitalized, or 10 episode of hospitalization, still be yes, haven't been hospitalized, which is not fair. One and many. Okay, so numerical count is appropriate to be the type of this. Even we say green tea can reduce rate of hospitalization. We can say rate here because it is about the number of hospitalizations in combined for everybody, for each group, divided by the person times under observations. During 12 months, some maybe can be observed half a year because they lost to follow up, for example. If we use the person times as the denominator, not just only the person, so this is the rate. Okay, as you can see, change the type of the outcome to be the numerical count. We write the conclusions in this way. So maybe the first times you are not clear what to put it here. But for now, just understand that it's really related on what will be presented, because we will present the incidence rate ratio. That is why we can say reduce rate, similar to the logistic regression, it is 0.7 to be able to say reduce about 30%. So the interpretation is the same when it comes to be a ratio. Then this is from what? From multiple Poisson regression. You see, it's really logically linked from this section about outcome to these sections about presentations and these sections about interpretations of it. And the last one, survival outcome, or sometimes we call event-free duration. An example is the effect of green tea on stroke among CKD patients, chronic kidney disease patients. The outcome is the first stroke, not any stroke. If any stroke, it's become the Poisson count. The first stroke means times from diagnosis of CKD to the first stroke is the outcome here. So this is the survival or event-free durations. The event here is the first stroke, a type of cardiovascular disease. Okay, it seems to be stroke is dichotomous. Yes, it is. But people who have stroke in very early, like 1 week after diagnosis of CKD, or 1 year or 10 years after CKD, is different. You know, even the two subjects in my example having stroke. Therefore, if we handle stroke as the dichotomous, it's not fair. So, survival outcome lead to this statistical methods is called Cox regressions, and the coefficients of this one give a hazard ratio. Interpret the same way as I put. I just want it to be not another issues for you to be complex, so I put it the same. And lead to this conclusion. So I hope you can see how each component in the mock abstract can guide you of how to plan for statistical analysis, both the plan, the details plan, and the presentations, as well as the interpretations in the conclusions.